Welcome to David Alexander Maths Tuition. This is chapter 11b on integrating f brackets ax plus b. Okay, so let's take a look at our first example. What is the integral of the cos of 3x plus 5? Now, all of these examples I'm going to solve using what is referred to as the guess and check method. Now, we know, or hopefully we know, that sine differentiates to cos, so the integral of cos is sine. So I'm going to guess that the integral of all of this is the sine of 3x plus 5. Now what I'm going to do is perform a check. Now sine goes to cos, so it's going to be the cos of 3x plus 5 multiplied by the derivative of what is in the brackets. Now the derivative of 3x plus 5 is 3. So the if I differentiate the sine of 3x plus 5, I get 3 cos 3x plus 5. Okay, now we are integrating the 1 cos of 3x plus 5. So we can clearly see that our guess of the sine of 3x plus 5 is not correct, because that is giving us 3 times too many cos of 3x plus 5s. So therefore, what we need to do is divide this through by 3. So we can either write all of this over 3, or just 1/3 times the sine of 3x plus 5 plus c. And if we want, we can do another guess and check if we want, except this isn't really a guess. We've shown that this is correct, but if you're not sure while you're starting out, you might want to do this just to be on the safe side. Okay, so that is going to differentiate to 1/3 times the cos of 3x plus 5, remember sine goes to cos, multiplied by the derivative of 3x plus 5, which is 3, and 1/3 multiplied by 3 is 1, so they will cancel each other out. So we can see that we have successfully differentiated 1/3 sine of 3x plus 5 to the cos of 3x plus 5, so therefore the cos of 3x plus 5 will integrate to 1/3 of sine 3x plus 5 plus the c. Here's another example, the sine of 7x minus 3. So let's have a guess. We know that minus cos differentiates to sine, so let's go for the minus cos of 7x take away 3. So let's perform our check. We know that cos goes to positive sine, and that's going to be multiplied by 7. But we don't want 7 sines of 7x minus 3, we just want 1, so therefore we need to divide this by 7. So that's going to be minus 1/7 cos of 7x take 3 plus c, or of course you could write minus cos 7x minus 3 divided by 7 plus c. That's also fine. Okay, so let's look at this one. What differentiates to sec 3x tan 3x? Well, that is sec 3x. Well, we know that sec goes to sec tan, so let's perform our guess of the sec of 3x. So let's perform our check. So that is going to be the sec of 3x tan of 3x multiplied by the derivative of 3x times 3. So that is 3 sec 3x tan 3x, but we don't want 3, we only wanted the 1, so therefore our guess is 3 times too high, so we're going to need to divide this by 3. So that is going to be sec 3x over 3, or 1/3 sec 3x. And don't be tempted to try and cancel these 3's. Maybe this bit, these could well be in brackets. So there we have it. 1/3 sec x, 1/3 of sec 3x. Of course, don't forget the plus c as well. Okay, so here we've got two functions going on. So we're going to have to do 2 guesses and 2 checks. So we know that sine differentiates to cos, so I'm going to guess it's the sine of 2x, but when I perform my check, that will give me 2 cos 2x, which is twice as big, so therefore I'm going to have to half it, so that's going to be 1/2 the sine of 2x. And with this one, let's perform a guess. We know that this is positive sine, so I'm going to guess it's a minus cos of 4x, but when I perform my check, I'm going to get positive 4 sine 4x, and we only wanted 3. So if we wanted 3 but we're getting 4, then we need 3/4 of this. So therefore we need 3/4 of our guess. So that's going to be minus 3/4 cos of 4x. And again, if that seemed a bit confusing, just experiment by differentiating. 3/4 times 4 gives us that 3, and minus cos goes to sine. And of course, plus the c. Okay, so with this one we need to be thinking what differentiates to cosec squared, and that is cot. So my guess will be the cot of 1/2 x. Let's perform a check. So that's going to be minus cosec squared 1/2 x multiplied by 1/2. So minus 1/2 of cosec squared 1/2 x. Now we didn't want minus 1/2, we wanted the full one, so therefore we're going to need double the amount. So that's going to be 2 times the cot of 1/2 x plus the c. And again, 2 times 1/2, that gives us the 1, and cot gives us the minus cosec squared. Okay, here's another one. So we've got minus cosec cot, so hopefully we know that cosec goes to minus cosec cot. So let's try our guess of the cosec of 3x. So when I perform the check, that is going to be minus cosec 3x cot 3x multiplied by 3. But we don't want 3. We don't want minus 3. We want minus 1/2. So we have 6 times more than we need. So therefore we need to divide this by 6. So that is going to be the cosec of 3x over 6. So cosec 3x gives us the minus cosec 3x cot 3x, and then we're multiplying the 3x by 1/6. And 3x, sorry, maybe I said that wrong. We're multiplying the 3x by 1/6, and 3x multiplying 3 by 1/6, and 3 over 6 is 1 over 2 plus the c. Sorry, I got a bit tangled up there. Hopefully that made sense though. Okay, here's another example, 5e to the 3x. So what we're going to do is we're going to ignore the coefficient and just guess that it's e to the power of 3x. Right, let's perform a check. So it's e to the power of 3x multiplied by the derivative of the 3x times 3. So that is 3e to the 3x. Now we don't want 3, we want 5. Okay, so what do we need to do? Well, that is going to be, we need 5/3 of 3. 5/3 of 3 is 5. So that is going to be 5/3 e to the power of 3x plus c. And again, we can do another guess and check if we want. 5/3 multiplied by 3 gives us the 5 e to the 3x. So we know that's correct. Okay, here's another example. So my guess, I'll put a G for guess, is e to the power of 5x. My check will be 5e to the 5x. And we want more than 5, so we are going to have to do 8/5 of e to the 5x. So that's 8/5 times e to the power of 5x plus c. And just do a double check if you're not sure. 8/5 times 5, well, the 5's will cancel, that will just give us the 8. 17e to the 4x, my guess will be e to the 4x. If I perform my check, I'll get 4e to the 4x. Well, that's not enough, so I need 17 over 4. So 17 over 4, e to the power of 4x plus c. 17 over 4 times 4 gives me that coefficient 17. So these are the sorts of questions where people sort of struggle to know what to do, and they might try and write this as 3x plus 4 to the negative 1 and get a bit tangled up. But generally speaking, I'm trying to think if there would ever be an exception, but when the denominator has no power, experiment with the ln function. So let's do our guess, which is the ln of 3x plus 4. So let's perform a check. So remember, we need to differentiate the stuff. So the derivative of the stuff is 3 over the stuff 3x plus 4. Okay, so we can see how we're getting that denominator, but we've got 3 when we do our check when we should only have 1. So this is 3 times too big, so therefore we will need to divide our guess by 3. So therefore it's going to be 1/3 multiplied by the ln of 3x plus 4 plus the c, or ln of 3x plus 4 all over 3 plus c. Okay, here's another example. So the denominator has no power, so I'm going to guess the ln of 6x plus 5. Let's do a check. So that's going to be 6 over 6x plus 5. Well, that's 6 times too big, So therefore my guess is also 6 times too big, so I need to divide that by 6. So that's going to be 1/6 the ln of 6x plus 5 plus the c. And again, once we've got the 1/6 in front of you, still not sure, then we'll just go through just do a second guess and check just to confirm that when you differentiate this, you definitely go back to 1 over 6x plus 5. Okay, here's another example. So my guess is going to be the ln of 2x plus 5. And if I perform my check, that is going to be 2 over 2x plus 5. And I wanted 3 over 2x plus 5. So therefore, I'm going to need 3/2 of the ln of 2x plus 5. So I'm going to multiply this by 3 over 2. 2 times 3 over 2, that would cancel out and would give me 3 over 2x plus 5. Anyway, so there we go. 3 over 2, ln of 2x plus 5 plus the c. Okay, let's take a look at this one. So I'm going to go with my guess. So here we've got a negative value for x. I'm going to guess the ln of 1 minus 8x. So let's do a quick check. So that is going to be minus 8 over 1 minus 8x. So the denominator is perfect. However, the sign of this is negative, but I need a positive. So simply by putting a minus in here, that will fix that and turn it into a positive 8. So, well, we've got an 8, not a 7, but at least it's positive. So the minus ln of 1 minus 8x is a step in the right direction. So we've ended up with 8 when we needed 7. So we need 7/8 of this amount. So that's going to be minus 7/8 times the ln of 1 take 8x plus the c. Okay, so here onto some slightly easier ones. So 4x plus 7 to the power of 6. So what we're going to do is just guess. We know that when we integrate, we increase the power by 1. So let's go with 4x plus 7 to the power of 7. So let's perform a check. Power comes down to the front, reduce the power by 1 and multiply by the derivative of what's in the brackets. So that's going to be 28 lots of 4x plus 7 to the 6. We didn't want 28 lots of 4x plus 7 to the 6, we just wanted 1, so therefore we want a 28th of this, so that's going to be 1/28 of our guess, so 1/28 of 4x plus 7 to the power of 7 plus c. Okay, here's another one. So first of all, the best thing to do is to rewrite this as the integral of 3x plus 2 to the negative 3 dx. So my guess is going to be 3x plus 2. Be careful here, it's not minus 4, of course it's minus 2. Let's do a quick check. Power comes down to the front, increase the power by 1 and multiply by the derivative of what's in the brackets times 3. So that's going to be minus 6 lots of 3x plus 2 to the minus 3. Okay, so there is my, the 3x plus 2 to the minus 3 is correct, but we only wanted 1, not minus 6. So we need to multiply our guess by minus 1/6. So that's going to be minus 1/6 3x plus 2 to the power of negative 2 plus c. Okay, here's another example. So I'm going to rewrite this as 2 lots of 3 plus 7x to the power of negative 6. What am I going to do for my guess though? I'm going to ignore the power. Sorry, I'm not going to ignore the power. I'm going to ignore the coefficient here. I'm going to guess 3 plus 7x to the power of negative 5. Let's perform a check. Power comes down to the front, reduce the power by 1 and multiply by the derivative of what's in the bracket. So that is going to be minus 35 lots of 3 plus 7x to the minus 6. And we didn't want minus 35, we wanted 2. So first of all, we've got a positive number, not a negative number. So if I make this negative, at least that will turn it into a positive 35. So that's a step in the right direction. But we've got 35 when we needed 2. So we need 2/35 of this, because 2 over 35 times 35 will give me 2. So that is, we need 2/35 of our guess. So minus 2/35 of 3 plus 7x to the minus 5. And you could write that as minus 2 over 35, 3 plus 7x to the power of 5, if you prefer. That's also, oh, but don't forget the plus c, don't forget the plus c. Okay, so here's an example where we are evaluating. So nothing new really. So first of all, I would write this as 6 lots of 3x take away 2 to the power of negative 3. Right, let's do a guess. So I'm going to ignore the 6. I'm just going to guess that it's 3x minus 2 to the minus, increase the power by 1, minus 2. The reason I'm ignoring the 6 is because I know that when I differentiate this, there will be a number popping out the front, and you never know, it could be 6, in which case I'll have nailed it straight away. It's unlikely to be 6. Well, we'll see what happens. So power comes down to the front, reduce the power by 1 and multiply by the derivative of what's in the brackets times 3. So that is minus 6 lots of 3x minus 2 to the negative 3. Actually, that's pretty good. We wanted 6 though, not negative 6. So all we need to do is, our guess was wrong, but if I make our guess negative, then that will turn this positive. So therefore, the integral of all this stuff is minus 3x minus 2 to the minus 2. But we want to evaluate this between the limits of 4 and 1. So first of all, I would probably write this as minus 1 over 3x minus 2 squared, again between the limits of 4 and 1. So let's just do our two brackets. So it's minus 1 over 3 times by 4, which is 12, take away 3 times 4 is 12, take away 2 is 10, 10 squared is 100, and this is minus 1 over 3 times 1 is 3, 3 take away 2 is 1, 1 squared is 1. So here I'm just subtracting 1, but I'm subtracting minus 1, so that is adding 1. So I'm sort of running out of space here. So that's going to be minus 1 over 100 plus 1, which is the same as 1, take away 1 over 100, so it is 99 over 100, or 0.99. Okay, so the integral, the definite integral is 0.99. So here's another example using trigonometry. So what differentiates to sec squared? Well, the answer is of course tan. So my guess is going to be the tan of 2x. So let's check this. That's going to be sec squared 2x multiplied by the derivative of 2x, which is 2. So we're getting 2 sec squareds when we only wanted 1 sec squared. So my guess is 2 times 2 big. So the adjustment will be, I just need to half it. So that is going to be 1/2 the tan of 2x between the limits of 2 pi over 3 and pi over 3. Now I can take the half outside, so that is 1/2 brackets tan 2x 2 pi over 3 and pi over 3. So this is going to be 1/2 multiplied by, just do one big bracket here and then two smaller brackets, one minus the other. So the tan of 2 times 2 pi over 3. So that is the tan of 4 pi over 3. And if I tan that, I get root 3. Take away the tan of 2 times pi over 3. So 2 pi over 3, so 2 pi over 3. And if I just tan that, what do I get? I get minus root 3. So what I have here is 1/2 lots of root 3 minus root 3, which is 2 root 3, and of course 1/2 times 2 root 3, so the answer is simply root 3. Now when you type this into your calculator, it is very possible that your calculator will not be able to give you root 3. It might well give you an answer as a decimal, so you might want to just double check that the decimal equivalent of root 3 is the same as what your calculator is giving you when you just type it in as is. So always use your calculator to check your answers, because it's so great when you're in an exam and you know that when you type, it's just nice to know you've definitely got the answer right, basically, isn't it? Okay, so here are one or two more examples where we're just using this guess and check method. So there's a few bits and pieces that are quite easy. For example, 4x cubed, increase the power by 1, divided by the new power. 4 divided by 4 would just be 1x x cubed. However, the 2 sine 3x and this fraction on the right is a little bit nasty. So let's just do a guess and check for the 2 sine 3x. So I know that minus cos goes to positive sine, so my guess would be minus cos 3x, which will become sine of 3x multiplied by 3, and so that is too big, so therefore my guess is too big, so I want 2/3 of minus cos of 3x, so that's going to be minus 2/3 cos 3x plus x to the power of 4, and with the 6 over 4x plus 5, my guess is going to be the ln of 4x plus 5. Remember, when there's no power on the denominator, a guess of the ln of that is a good guess. So that's going to be the derivative of the stuff over the stuff, and I've got 4, not 6. Okay, so therefore I want 6/4 of this, because 6/4 times 4 will give me the 6, and of course 6 over 4 is 3/2. So it's going to be 3/2 of the ln of 4x plus 5 plus the c. So quite a tricky one, only because there's more than one thing where we need to apply that guess and check method. Okay, here's another example. So for e to the 2x, my guess would be e to the 2x, but when I check that out, I get 2e to the 2x. So my guess is too big, so I need to half it, so that's going to be 1/2 of the guess, so 1/2 e to the 2x. Now cos of half x, my guess would be the sine of 1/2 x, and when I do my check, that will be cos of a half x multiplied by a half, but I didn't want a half of cos x, I wanted 1 cos x, so my guess was too small, so I need to double that, so that I'm doubling my half cos of half x, so that's going to be plus 2 sine 1/2 x. And okay, let's have a look at this one. So I'll just put in the minus sign. So just remember that 2x plus 2 squared is 2x plus 2 to the minus 2. So a good guess would be 2x plus 2 to the power of minus 1. Let's check this. So that's going to be minus 1 lots of 2x plus 2 to the power of minus 2 multiplied by 2. So that is going to be minus 2. Now, okay, so remember I'm aiming for positive 1 because I have already put down this minus sign here. So yeah, so remember I'm just focusing on this without the minus. That minus is taken care of there. Okay, so I wanted 1, but I've got negative 2. So if I want a positive number, not a negative number, then I just need to make this, by making this negative, I make that positive, and I've ended up with 2 when I wanted 1, so I need half of this. So it's minus 1/2 of 2x plus 2 to the minus 1, and of course the minus minus, we can now turn that into a plus. Perhaps it would have been easier just ignoring that and then just seeing this as seeing if I can get a minus 1. So it's up to you whether you want to ignore the minus sign or not ignore it. And don't forget the plus c as well. And of course the half 2x plus 2 to the negative 1 we can write as, we could have written that as 1 over 2 lots of 2x plus 2, which we could have written as 4x plus 4. So there we have it. Okay, so we're going to have to do a lot of guessing and checking with this one. So e to the 2x, let's just guess e to the 2x. The derivative of that is 2e to the 2x, that's twice as big as that. So our guess was 2 times 2 big, so I should have halved it. So it's a half of e of 2x. A guess for the cos of a half x would be the sine of 1/2 x. But when I differentiate the sine of half x, I'm going to get 1/2 cos 1/2 x. But I needed a full cos half x, so my guess was, I need to double my guess, so that should have been plus 2 sine of 1/2 x. And this last term, we might want to see this as, and what we can do is see this as minus 1. We can either ignore the minus or just include it and put it with the 1. So it's minus 1 times 2x plus 1 to the negative 2. Right, let's do a guess, which is this with the power increased by 1. Let's do my checks. That's going to be minus 1 looking good so far. 2x plus 1 to the negative 2, but I need to multiply it by 2, so that's minus 2 lots of 2x plus 1 to the minus 2. So I'm actually, my guess is twice as big as it should, it's 2 times too big, so therefore I need to half it. So that's going to be plus 1/2 2x plus 1 to the negative 1. And this term you could write it as 1 over 2 lots of 2x plus 1 if you wanted to. In fact, you could even write it as 1 over 4x plus 2. Okay, and don't forget the plus c, of course. Okay, so here's another example. So sec 2x tan x, what differentiates to that? Well, that is the sec x goes to sec x tan x, so a good guess would be the sec of 2x. Now my check would be sec 2x tan 2x multiplied by 2, but I need 6, so my guess needs to be tripled, so that's 3 times the sec of 2x. Okay, so what differentiates to cosec squared? Well, the answer is cot. Well, specifically cot goes to negative cosec squared, so I'm going to guess the cot of 4x, and when I check that's going to be minus 4 cosec squared 4x. So my guess is too big, and I need 3/4 of that. So 3, because 3/4 of 4 is 3. So it's going to be positive 3 over 4 cot 4x. So for the minus 3e to the 7x, my guess will be e to the 7x, and when I check, that will be 7e to the 7x. First of all, I need a negative number, so by making that negative, that will be negative. And I don't want minus 7, I want minus 3. So what do I need to do to turn that 7 into a 3? I want 3/7 of that, so it's going to be minus 3/7 e to the power of 7x. And for this final one, my guess will be, because there's no power on the denominator, the ln of 2x plus 4. When I do my check, that is going to be 2 over 2x plus 4, and we wanted 3 over 2x plus 4, so therefore I need 3/2 of the ln of 2x plus 4 plus c. There we go. Okay, so here's one final example. So we want to work out what the values of a are, such that the integral of 3x minus 4 between the limits of a and 2 is 340. So first of all, I'm going to integrate 3x minus 4 cubed. So I'm going to use the guess and check method. I'm going to guess that it's 3x minus 4 to the power of 4. So if I do a check, that's going to be 4 lots of 3x plus 4 cubed multiplied by the derivative of 3x plus 4, which is 3. So that's 12 lots of 3x plus 4 cubed. Now I only want 1, not 12, so my guess is 12 times too big, so therefore the integral is going to be 1/12 of the 3x minus 4 to the power of 4. And that is between these limits of a and 2. Okay, so let's substitute a into these limits of a and 2 into the 3x minus 4 over 4 over 12. So that's going to be 3a minus 4 to the power of 4 over 12 minus 3 times 2, which is 6. 6 minus 4 is 2, so 2 to the power of 4 is 16. 16 over 12, and 16 over 12, that is also minus 4/3. Okay, so what we know is that 3a take away 4 to the power of 4 over 12 minus 4 over 3 equals 340. So what I'm going to do is add those 4/3 to both sides and then multiply by 12. So therefore, if I just take my workings up here, so 3a take away 4 to the power of 4 equals what? So 340 plus the 4 over 3 multiplied by 12 is 4096. So therefore 3a minus 4 is the 4th root of 4096. So we need to remember that that's going to be a positive and negative answer, so plus minus 8. So 3a equals 8 or plus or minus 8 plus 4. So 3a equals 8 plus 4, which is 12, and 3a equals minus 8 plus 4, which is minus 4. So therefore a is 12 over 3, so positive 4, and also negative 4/3. So there we have the two values plural of a, so it's 4 and minus 4/3.